the film is the back of house, and now this is the performance, front of house, so no pressure on me. And so I've called it equation because I've kind of created a quasi-equation, which is really a problem that I put out there, in that if you said, impact, the impact of human beings is our growing population, so that's, let's call it P, times rising affluence, so let's call it A, so P times A. So those are growing components, so how do we balance it? And the only way of really balancing it is through technology. So it's kind of P times A times T. So T, I guess, has to be an integer because it has to reduce the overall sum. But let's broaden that T for technology because it's not just about technological revolution and evolution. It's also about ingenuity. So our future cities. Well, cities actually produce 80% of the global GDP on the planet. So what that means is there's actually an incredible resource to shape those cities and to rethink the future of those cities. But they consume 2/3 of the world's energy and produce 70% of the greenhouse gases. So what we must do as designers and architects is increase productivity and efficiency. And that comes through innovative technology, thinking and ingenuity. Well, I think the key to sustainability for Grimshaw should be for all architects. Because I think we're set with a unique series of challenges for the next 2 generations of architects and urban designers. So some of those cities took 2,000 years to evolve, and now we're creating a whole new set within a very short space of time. Now, when you think cities consume around 70% of the world's energy and produce an equivalent amount of greenhouse gases presently, clearly we've got to rethink how buildings work and how cities work. So at the macro scale, it's actually urban design, and if you like, in the micro scale, it's probably the building within the urban setting. And that's really what I want to also explore in the talk. Is it doesn't just mean using kind of very sophisticated photovoltaics or sophisticated computer programs to design certain aspects. Some of it may be just very simple. There's a lot of work being done recently in, let's say, engineered timber, where we can actually now use timber, which is obviously a resource that we can grow, that actually absorbs carbon as it's produced, and actually can now be used in quite sophisticated building solutions. Our research group at the moment is also exploring a completely new material which is entirely made out of recycled glass. And so it will enable us to, and we're looking at basically in the first instance housing in the UK, where we'll be able to print a house in about 2 hours using recycled glass, but more importantly, so it's obviously very, it's repurposing material, it's incredibly highly efficient in its level of insulation and structural integrity. So I think ultimately the challenge must be to find new industries that are disruptive. Because if we look back at architecture, the building industry hasn't really changed in, I would say, a millennium. 1,000 years, there hasn't been big changes. There's been a few changes, curtain walls, glass technology, and so on, but not a wholesale revolution. So a house today is built in America, it's built in more or less the same way as it was 100 years ago. The only invention has been a nail gun, but the rest of it's the same. And then you compare that to other industries, such as car building or car making or aviation. And, within 70 years, we went from the Wright brothers to landing on the moon. So clearly, I think there has to be similar things happening in the built environment if we're going to have a sustainable future. And so for us, it's really finding new ways of doing things that minimizes that kind of set of consumption. And I think, it's actually a really interesting and exciting challenge, because the other side of the coin is that cities actually generate around 80% of the global GDP of the planet. So if in a way, the funds are there, and the opportunities there, and actually we've really got to come up with solutions. So for us, it's really thinking things through from first principles. Now, often that doesn't just mean putting PVs on a roof or efficient ways of recycling energy. So I think sometimes people ask us, why are you so interested in innovation and research? And I think, as architects, we don't do prime research. I think the term innovation is the appropriate one, because often we're drawing upon research that's been done by others and developments from other industries and bringing them into the building industry. So, but the thing is, why do we do that? So we're not doing it just because of a kind of technological fetish, that we're really fascinated just for technology's sake. And rather than thinking of just technology and innovation, I would use the word ingenuity. Because sometimes the appropriate response might be using a really basic approach and technology. So, what is the long-term solution? And I think this is where architects and urban designers, and designers generally, have an enormous responsibility and set of challenges, because cities are where we're all going to be living, and inherently they have the opportunity of becoming very efficient and very sustainable, because they have a small footprint. We can use innovative transportation to link it all. We can use, our distribution isn't spread. So there's no reason why a city can't be, the future city, can't be a very green city, a very sustainable city. I've called my talk Equation, and it will hopefully it'll become evident when I go through some opening slides. Now, there's a few slides just setting the scene, and then I know many of you are architects and designers in the room, and what you really want to see are drawings and images and projects. So I promise not too many statistics, but they'll be interesting. So I'm going to now, we're all architects, graphically show you some statistics. So this is the world as we all know it, as a Cartesian projection of a three-dimensional form onto a two-dimensional map. This is done actually by a company based in Sheffield University, and they have a website, if you're interested, called World Mapper, and they project statistics into map form. So it's showing the world as a set of statistics rather than just landmass. So this is GDP Wealth this year, which is set by the IMF as $131 trillion. And so what you see is that all the money is in America and Europe. We kind of keep most of it there currently. And then set that against the current world population, which you see has already grown by almost 1 billion since our 10-year-ago slide to 7.6 billion. This part of the world has most of the money, but the population is all here. And this population is all wanting to grow to have all the things that we have here in Europe and in America. So this growing aspiration for wealth and consumption is going to radically increase the rate that we consume things over our generation. And at the moment, this part of the planet, if everyone was to use the same amount of resource, is using 5 planets worth of resource. So we would need 5 more Earths if everyone was to get to where we think we're going to get to by 2050. So, and again, this really captures that, so we don't need to go into detail, but what you see is currently carbon emissions 2015, the vast use is in the USA and Europe. However, we've actually been reducing our carbon emissions, actually, over the last few years. So this is actually a reduced picture than how it would have looked like even a few years ago. But if you look at that and compare it to where all the world's population is, then the more important picture is the growth of carbon emissions over the last 10 years, which picks a very different picture. So we're going to, in the part of the world which has all the population and it has a massive growing carbon emission footprint, that's where we're going to build the majority of all those cities. So we're going to replicate and increase and double all our cities in this part of the world. So you can see the incredible challenge that we face as urban designers, planners, architects, designers. And this needs to be put against time. So the planet is 4 billion years old, and most of us have difficulty in imagining what 4 billion looks like, well, unless you're Bill Gates. So, rethinking the lifespan of the planet into a year, what you would have seen is by March the first life forms appear on the planet, but humans don't appear till 15 minutes before midnight. And the first recorded history is 30 seconds before midnight, and the Industrial Revolution is 1 second to midnight in a year. So in the space of the lifespan of the planet, the impact we're talking about happens in the blink of an eye within a year. So a blink of an eye, and this has happened. So in the interest of time now, I'm going to say as little as I can and be precise as I can. I'm just going to touch on a few themes before we get to the final project that I hope illustrate some of our thinking at Grimshaw. So the first topic I've called Harvesting the Sun. We wanted to demonstrate how a sustainable architecture and a new approach could actually create a new vocabulary for architecture that was informed by a self-sustaining ecosystem. And then harnessing the wind. It's the idea of how a building can actually be formed to use the wind to both cool and ventilate it. So recently we've just opened a new Museum of Science in Miami. And at the beginning of the design process, we were actually given a government grant to research the design, to explore how we could use natural ventilation. So that's air coming off the sea to cool and ventilate the building. Now, many of you know that Miami is actually, it's quite hot and humid, but it never gets very cold, but it does rain in the summer. So as long as you shelter in the right way and harness those breezes, you can actually create a very enjoyable and attractive environment using no energy at all. So another good example of that type of performative approach was the station we designed in Australia, where the roof actually has an undulating shape. Now, there are lots of infrastructure projects and rail projects and airports which have interesting and unusual shaped roofs, but normally it's just a kind of whimsical approach, just in a way trying to create a shape just as a kind of signature. And we thought, well, what if you look at the two prevailing winds in Melbourne, and in the same way as a mogul field is created or desert dunes are created with the way wind moves and crisscrosses, what if you created a roof which is almost like a mogul field, and then you took that wind and it's like reverse engineering it, and that provided all the ventilation. And so it was a design, it was an idea. We tested it with CFD analysis. We then tested it with wind tunnel tests and so on and refined it. And indeed, we actually managed to remove all the machinery, all the equipment from the roof. So the shape of the roof is the entire environmental control system for the space inside. So what that means is there's no operating cost, there's no machinery. It just passively harnesses the energy that it has to hand. So the next topic I want to just briefly talk about is urban ecology and this importance of connecting people, inhabitants with nature that we've lost in our cities as they become kind of more and more built up. We're rethinking how the river works and brings life back into the city, and how greenery and a park can reunite and rebuild the entire city. German engineer Schleich that came up with the statement, just because you can doesn't mean you should. So let's explore what does that mean. Well, I think at the moment, within architecture, actually for the last decade or so, computers have liberated us from the drawing board. So we've been liberated from the set square. So we can actually form and develop kind of curved shapes. We can take that design all the way to manufacture through CNC. But just because you can doesn't mean you should, because there must be a reason for doing something. So I go back to this idea of performance and a performative approach. Because something is really elegant if it fulfills its function. And so what we're looking at is the appropriate way of doing something, the appropriate response to a given set of questions. This is the Amazonian rainforest, where I was fortunate to spend time on a separate research project. And probably many of you here, like myself, thought the reason why it's the most biodiverse part of the planet is because it's an incredibly rich and fertile part of the planet. So you ask, why does this tree have roots? This is a buttress tree, roots that are shaped like this. Unfortunately, I was with a very famous biologist called David Campbell, who has written fascinating, many books. This is one of his award-winning books, The Land of Ghosts. And what he described to me is that actually the whole rainforest as an ecosystem sits on a few inches of sandy soil with almost no nutrients, generates 70% of its own rainfall. And the reason it's there is because it's developed as a system with incredible efficiency, using ingenious design and using all its resources incredibly sparingly. So you can see nature can actually do and provide incredible wealth and richness, but using very minimal material and resource. We talked about learning from nature and how nature is an inspiration to our work. And in a way, one of the reasons why I think nature is an inspiration is it always does things in the optimal way, so the most efficient way. And so the elegance of the roof, I think, is that it does things in a sparing way, using the minimum of resources, and in my mind that gives it an inherent elegance and beauty. And that's why nature is so beautiful, because it has this inbuilt efficiency that gives it poise and ultimately creates a kind of timeless aesthetic. To look at the impact of how you might design a shape and form that responds to the wind and the breeze, in the way that a river can create a course in its own way through rocks, or the wind can move and shape the environment. We're creating an architecture that uses that environmental response to shape and form it. Well, of course, as architects, we're all individuals and all have our own unique approach to design. I think within Grimshaw, what we're really driven by is the idea of performance, really a performative approach to architecture and design. And by that, I mean a kind of a process that starts with a really rigorous understanding of the brief, a dialogue with the client, and then really going down and exploring with no preconceived ideas what might be the appropriate approach and solution that gives us the right way forward and the right design. So I think with Grimshaw, we say we don't have any kind of preordained stylistic design, but what you will find, there is a common thread through all our work. So it's undeniably a kind of Grimshaw project, yet it's wholly appropriate and a unique solution to each of the individual kind of challenges and questions that we're asked to resolve and look at. Yeah, I think scale is an interesting challenge because clearly the design philosophy can run throughout, but there are different approaches required and sensibilities required designing a city, in the way we're working currently in Albania on Tirana on the new master plan of their capital city, than designing a rail station or an airport, or indeed, the seat that goes in that airport or rail station. And we do that full range of scale of design. But I find it fascinating, and certainly within a building we've always placed a great deal of emphasis of the relationship between the kind of macro and the micro. And I think often if you look at some of our projects and you look at the big idea and the big concept, when you bury yourself down into the detail, you can still see the same philosophy running through into the individual details that make that project work. We were interested in working in different international locations, but from the outset we decided the way of doing that is to be immersed in the location you're working within. So what we didn't want to do was to have a kind of main headquarters in London and to fly in and fly out of different locations. So we very consciously took a different approach, and the idea of building up effectively a kind of connected network of global city locations, each working immersed in their environment but working collectively as one. And so I think we've had the benefit that all of the partners started their career and have been at Grimshaw for a very long time, and so we all know each other very well, and so that gives us a kind of sense of connectivity, and then we work hard to instill that throughout all our different locations. And very often we'll work across two different locations. So New York and London might work together on a project, which they are doing actually on several at the moment, or London and Sydney working on projects. And so that kind of dual approach also helps with the connectivity. And then finally, I think, and it's a great opportunity, particularly for some of our younger architects, but is to move across and work in different locations. And many actually of our senior staff have worked in at least two of our locations. And so that kind of moving staff around it also helps with this sort of cohesiveness. But I think it's a very important thing to remain conscious of the idea of connectivity. And so we put a lot of focus on communication, not just, so it's not communication externally, because of course that's a different thing. It's actually making sure all of our staff feel connected. And just recently, we've invested a lot of time and effort into a new intranet system, which we've called Atlas. Obviously, it's called Atlas because it's helping us navigate the world. And we found that to be an incredibly strong platform, enabling us to actually share ideas. So sharing things both from a kind of intellectual way, and so people are aware of different projects we're working on and different areas of research that are happening. But also in a social way, because I think we're quite a social office, and we enjoy our events and enjoy family and enjoy sharing news of new babies and things like that. And I think all of that creates a sense of community. And so ultimately what we're really interested in doing is creating a kind of strong Grimshaw community. And by doing that, I think that gives us a kind of inner strength to then propel into our design work and our external efforts. So many of these themes are captured in the last project I'm going to look at, which is the World Expo in Dubai in 2020, which obviously follows on from the very successful World Expo here in Milan. So it's the next major international expo. So as with all expos, it has a theme. I think it's called Connecting the Mind, and it has three subset themes: mobility, opportunity, and sustainability. And each has its own district. The central district is sustainability, And what we're doing is the sort of main anchor pavilion that will become, in the long term, a major new institute and research institute for the UAE. And it's, it's an ambitious undertaking. In 36 months, I think they have now 40,000 people working round the clock, 7 days a week. So to put the scale of what has to be finished in the next 2 years, this is placing it over central London. So that's our sustainability pavilion. That's Trafalgar Square. This is all of kind of the middle of central London. So it's really like building an entire new city that must be complete, and our building must be complete at the end of next year. So when we were asked to do the competition for the sustainability pavilion in Dubai, we were at once hesitant because in a way it sounds like an oxymoron in the idea of sustainability in the desert. But we thought if we could demonstrate you can do a net zero building that's totally self-sustaining in the world's harshest environment, then you can do it anywhere. And thinking that it expects to have 25 million visitors over 6 months. What an incredible opportunity and worldwide audience to demonstrate, the future that architecture could hold. So first of all, you work with what you have. So we have the ground. So the building is both sunk into the ground and we lift the landscape over the building. So most of the inhabited conditioned part of the building actually uses the ground as a natural heat sink and insulator. And then over it we have this canopy that shades the whole building. Now I'm going to try and summarize this quite complicated technical diagrams in 3 or 4 words, see if I can do it. So, using the best design approach for the most sustainable building, similar to the building we're doing, this is the energy consumption, with almost half the energy generated on by the building and half coming from outside. So, to be net zero, we need to improve what we can generate on site, and then remove and redesign everything, so we need no energy from outside. So we can't change this much, so we have to re-engineer all of this to halve the energy consumption. So net zero means everything, which also means generating all of our water and recycling our water so that we are totally self-sufficient. Again, this would be a very well-designed building on how you would manage and use water to the minimum. So the roof canopy and all the E-trees, which we'll talk about, are the kind of technological solution that drives our sustainability. But whereas the canopy is technologically very advanced, much of the building is very simple. And so most of the cladding is, actually I'm looking forward to saying gabion, because I think the gabion was invented in Italy. So it's very simple construction grounded in the landscape using material from the landscape. And the landscape actually is a major part of the exhibition, and so again we're being quite experimental with the landscape. We're using many plants from the region, many of which have not been used in a landscape, so they're plants that we're experimenting and researching with our landscape and ecology team. And so the canopy above is almost like a gaff tree, which you find in the desert. Whenever you find one, you'll find people sheltering and enjoying the bounty of the shade it provides. So it captures all that harmful energy, all that harmful heat, and it turns it into an incredible energy resource, and also funnels the light down to the very heart and core of the building. So the canopy is almost like a mechanical leaf, harvesting energy through photosynthesis, providing shelter. So this is the elevation of the canopy. It's a big structure. It's 120 meters across as a cantilever. And the structure is actually made of carbon fiber, so that it's very light and efficient, and that allows us to motorize it. So like a sunflower tracking the sun, these spend the day tracking the sun for optimum efficiency. But inspiration, this is the dragon blood tree that's found just off Yemen. And it's one of the few plants that can pull water out of the air with its waxy leaves and provide shelter below. And so this was the inspiration for our E and W trees. And the W trees generate water. It's one of the ways we generate water, a bit like a fog beetle. So it draws water at night when it's cooler but still humid, And we're developing a new technology with MIT, which is called Metal Organic Framework, which is a nanotechnology that lets you pull water out of the air like a sponge and generate litres of water within a cubic metre of the material each day. So if I'm lucky to meet some of you at the Expo in October 2020, or it runs from October to April, we can meet under here and you can walk up on top of the building through the landscape, and still under the canopy right on the top on the roof, the canopy soars above you. You can have a drink and you can look over the entire Expo site. So hopefully some of you will manage to make the journey to Dubai, where there's a lot more to see than our pavilion, and I'm sure it's going to be a very exciting World Expo, as they always are. Thank you.